Okay, hello everyone. So today we'll be going through this exercise 8.2 from the new Discovering Math Sec 3 3B textbook. Yes, I think it's 3B if I remember correctly. Yep. Okay, so let's take a look at the question 5. So question 5, anyway, I was saying this is from exercise 8.2. So let's take a look at question 5. So in the diagram, RT represents a vertical tower of height 42 meters. So as you can see in the diagram, right, RT or TR, right, is the height of the tower, okay? And then this is 42 meters, so it's already labeled here. And then R is on level ground. So P, Q, R are all on level ground, right? The next sentence. Then they said, the angle of depression of P from T is 36 degrees. So this is the angle of depression over here, right? From T of P, okay? And then the angle of depression of Q, right, from T is actually 59. So as you can see, the big angle here over here. Okay, so they want us to find the distance of P and Q. So they want this. All right, so basically the first thing that come to my mind is I need to find out what is the length of PR, and then I need to find out the length of QR. And when I minus these two together, it will give me PQ. Okay, so that's the first thing that come to my mind lah. All right, so let's find PR first. Okay, so if you want to find PR, right, you need to focus on the big triangle like that. Okay, so this is P, this is R, and this is T lah, right? So we want to find PR, right, the big one. And then we know that TR is 42, and this is a vertical tower, so that's why angle PRT is 90 degrees. All right. Okay, so definitely we need one more angle lah, right, in order to find the length here. All right, so as you can tell, we need to find angle PTR. Okay, so for angle PTR, right, for angle PTR is going to be 90 degrees minus 36 degrees, and that will give me 54 degrees. All right, so this is 54 degrees. So now we can find PR already by using what? Tuakaso law, right? So tangent 54 degrees equals to PR over 42, right? Opposite over adjacent. So this is the opposite, this is the adjacent. Right, so PR is equals to 42 times tangent 54 degrees, and this will give me 57.808. All right, so that's for PR. Now we need to find PQ. So I'm going to write in blue, maybe black. Yeah. Okay, so we want to find QR now. So for QR, you need to focus on another triangle, QRT. So same thing, RT, the tower, 42 degrees, right? And then angle PRT is also 90 because it's a vertical tower. All right. Then QR is the length that we want to find. So we need angle as well. So how do we find this angle QTR? So angle QTR, right, is equals to 90 degrees minus 59 degrees. Okay. And this will give me 31 degrees. So this is 31 degrees. All right, so same thing, tangent. Okay, we're going to use Tuakaso. So tangent, right? So tangent 31 degrees equals to QR over 42. Okay, sorry. So QR is equals to 42 times tangent 31 degrees. All right, and this will give us the 25.236. All right, so last one, last step. Okay, maybe in black, in blue. So last step, PQ is going to be PR minus QR, right? From the first thing that we discussed. So PR is 57.808 minus 25.236. So the outcome will be 32.571 round off to 32.6 meter. Okay, so the distance between P and Q is 32.6 meters, 3 significant figure. All right, okay, so this is it for question 5. Okay, let's read question 6 together. So in the diagram, TF, right, this TF is a vertical tower, right, and then it's on level ground AFB. Okay, so AFB is on level ground. The angles of depression of A of A and B from T, right, is 41 degrees and 28 degrees respectively. All right, then they said, oh, since if AT is 56 meter, find the height of the tower. Okay, so first thing first, part A, how do we find the height of the tower? Right. So I want you to focus on the triangle, this TAF here. Okay, since the angle of depression of A, right, from T is 41, so that means I can say that angle TAF is equals to 41 degrees, right? And then this is because of alternate angle, comma, parallel lines, right? Yeah, so the horizontal eye level, right, is parallel to AF because of parallel lines lah. Okay, so that's why this is 41 degrees. So how do we find TF, which is the height of the tower, right? So we're going to use Picasso law. So opposite over, so this is opposite, this is hypotenuse, this is adjacent, right? So we are going to use so. So sine 41 degrees equals to TF over 56. So TF is equals to 56 times sine 41 degrees, which will give us 36.7393 rounded off to 36.7 meters, 3SF. Okay? Oh, crap. I didn't write S. Okay, 3SF. Yeah. Okay, so this is for part A. Right, so part B. So find the distance AB. All right, so okay, I'm going to erase this. So they want distance AB, right? So means we can actually, so we can actually find what is AF and what is FB, and then just add them together to give us AB, right? Okay, so first thing, how do we find AF? Same thing, use the triangle just now we mentioned, TAF. So Picasso again. So this is adjacent, right? Hypotenuse and opposite. So we this time round we are going to use CA. So cosine 41 degrees equals to AF over 56. Or if you want to use Pythagoras theorem to find AF is also fine. Okay, so AF equals to 56 cosine 41 degrees. Okay, I'm just going to leave it like that because later when I when I key in AF plus FB, I can just key in this directly. Okay, so this is AF. All right, then the next part, I want to find FB. Okay, FB. So first thing, we know that angle TBF is also equals to 28 degrees because of alternate angle. Same reason as for angle TAF. So alternate angle, parallel lines. Okay, so this is 28 degrees. And from part A, I have found out that my TF is actually 36.7393. All right, so I can find FB, right? So how to find FB? So label, right? So this is opposite, this is adjacent, this is hypotenuse. So opposite and adjacent. So tangent law. So tangent 28 degrees equals to opposite, which is 36.7393 over FB, right? So FB is just equals to 36.7393 divided by tangent 28 degrees. Okay, I'm just going to keep my answer like this for now. Then after that, last step, I want to find AB, right? So AB equals to AF plus FB, right? So what was AF? 56 times cosine 41 degrees plus FB, which is this 36.7393 over tangent 28 degrees. And then we just calculate. Right, so my final answer will be 111.3602 round off to 111 meters. Three significant figure. Okay, so this is my answer for 6B. All right, 111 meters. And this is it for question 6. Let's take a look at question 7. So in the diagram, TF is a vertical building on level ground, ABF, when AB is 80 meters. So it's given and it's on the diagram lah. So the angles of depression of A, right, and B from T, right, are 32 and 43 degrees respectively. So let's take a look at for the depression of A. right? So depression of A means I will draw a horizontal eye level, right? Something like that. Okay, so 43 degrees is this. No, sorry, 32 degrees because that's for A, right? So 32 degrees. All right. Maybe I should write smaller lah. Okay, so this is 32 degrees. And then for the B, right, is 43 degrees. So this is 43 degrees. Okay. Yeah, that's what they meant. So find part A, find the distance AT. So they want this distance over here. This is AT. All right. Okay. Yeah. So basically, in order to find AT, okay, let me see. I will actually want to use sine rule to do it actually. Yeah. Okay, so means right, I need to find out my angle ATB. Okay, we need to find out angle ATB, which is equals to 43 degrees minus 32 degrees, and that will give us 11 degrees, right? So that is 11 degrees. And also we need to find out our angle ABT, this angle over here also. So let's take a look. Okay, we can say that angle ABT, right? Angle ABT is equals to 180 degrees minus 43 degrees. How come? Because this, so if you see, it's like that. So this is like A, B, T. Then our eye level is over here, right? So this is 43 degrees, right? Right? So it's like an interior angle because this is parallel to this, right? So 180 minus 43 equals to 137 degrees. And then this is interior angles. Okay, interior angle, parallel lines. Okay, parallel lines. All right, so now I have 137 degrees here already. Right, so now we can do sine rule to find AT. So I will say AT over sine 137 degrees equals to AB, right, over sine 11 degrees. So AB is 80 lah. So AT over sine 137 degrees equals to 80 over sine 11 degrees. So AT equals to 80 over sine 11 degrees times sine 137 degrees. And the length of AT will be 285.939 round off 3SF. So 286 meter. Okay, so AT, oh no, sorry, this one. AT is 286 meter. Okay, so I'm just going to fill in the blanks here. So 285.939. Sorry. Yeah. Okay, so let's move on to part B. Going to do it in black. So the height of TF. Okay, so we want to solve for TF, right? Okay. First thing first, I know that angle TBF, right? TBF, this angle here is actually 180 degrees minus 137 degrees, right? Or you can do alternate angle, whichever lah. It will be the same thing. So equals to 43 degrees. And then I just going to say adjacent angles on a straight line. All right. Okay, so this is 43 degrees. And then they want us to find TF, right? I'm thinking of using Tuakaso. So that means I need to have one of the length. So let me find TB then, right? Since we have the stuff there, right? So we can actually find TB lah. All right. So TB we can use sine rule for TB, or you want to use cosine rule for TB also can, no problem. Okay. So first thing first, let's say I want to use sine rule, right? So for sine rule, I need to find out my angle TAB first. Okay. So angle TAB equals to 180 degrees, right? Minus 11 degrees minus 137 degrees. And that will give me 32 degrees if I am not wrong. Let me calculate. Yes, 32 degrees. Okay, yeah. So here we go. Then we can use sine rule already lah. So TB, right, over sine 32 degrees equals to 80, right? 80, which is AB, over sine 11 degrees. Okay, and then fast forward, right? So TB is equals to 80 over sine 11 degrees times sine 32 degrees, and that will give us 222.1778. Okay, so TB here is 222.1778. Okay, so now can find TF already using Tuakaso. Okay, so the reference angle is 43 degrees. So this is opposite, this is hypotenuse. So I'm just going to use sine. So sine 43 degree, whoops. Just hold on for a moment. Okay, sine 43 degrees equals to opposite, which is TF, over hypotenuse, 222.1778. So TF will just be 222.1778 times sine 43 degrees. All right, so TF will be 151.524. All right, round off 3SF, 151 meter, no, sorry, 152 actually, 152 meter, 3SF. Okay, so yeah, yes, so this is it for question 7. Let's take a look at question 9. So there's a diagram here, so it's supposedly easier, right? So in the diagram, AB is an advertisement board, right? Perched on, so this is an advertisement board, and it's perched on a vertical pole BC. So this is a vertical pole. So point CD are on horizontal level ground, right? So AB is 3, AD is 12, and BD is 10. So find the angle of elevation of A from D. So this is the angle of elevation that they want. This is the angle that they want you to find. All right. So basically, right, what I was thinking is you can actually find angle BAD first, right? So you have this, then you have 90, right? Then you can find this big angle already. Okay, so that's the thinking process lah. Okay, so first thing first, how to find angle BAD. Okay, so if you focus on triangle ABD, right, you have all the three lengths of the three sides. So you can do cosine rule actually. All right, so 10 square equals to 3 square plus 12 square minus 2 times 3. My 3 doesn't look like 3. 2 times 3 times 12 times cosine angle BAD. All right. So cosine angle BAD equals to 10 square minus 3 square minus 12 square divided by negative 2 times 3 times 12. All right. So angle BAD is just cosine inverse all this lah. So equals to cosine inverse. So if you calculate this, you will get 53 out of 72. All right. And this will give you 42.5988. So this angle here, 42.5988. Okay, so how to find angle of elevation, which is angle ADC lah. So angle DC equals to 180 degrees minus 90 degrees minus 42.5988, and this will give me 47.4011. So round off 1 dp, 47.4 degrees. So this part here, the entire part here, okay, I should not shade it like that. The entire part here is 47.4011 degrees. Okay, so because they ask for angle of elevation, so I think it's better to write lah. So the angle of elevation of A sorry, from D is 47.4 degrees. Okay, so this is for part A. Okay, so let's do part B. So part B is over here in red. So the angle of elevation of B from D. So they want this angle over here. Okay, they want this angle over here. So what I can think of is I'm going to find, okay, I'm going to find CD. Okay, I'm going to find CD. All right, how? Focus on triangle ABC. So I draw, so A, no, oh no, not ABC lah. ACD, sorry. ACD. Okay, so AD is 12, right? And then CAD, I have the angle. This is the 42.5988, right? So I can use Picasso actually, right? Cos 90 degree here. Okay, so reference angle is here. So this is opposite, this is hypotenuse. So use sine law. So sine 42.5988 equals to opposite, which is CD over 12, right? So CD is actually 12 times sine 42.5988. And this will give me, let's see. Oh yeah, okay. I just realized my calculator is in radian mode. So you got to change it to degree mode before you can make sure that you change it to degree mode for this question. Because if you are in radian mode, all your answers will be wrong. Okay, so you will get 8.1223. All right, so this CD is 8.1223. All right, so how to find this angle CAD, right, is Picasso again. So this is the angle that we want to find. So this is the adjacent, this is the hypotenuse, right? So cosine. So cosine angle BDC equals to adjacent 8.1223 over 10. Hypotenuse is 10. So angle BDC is equals to cosine inverse this value, right? And it will give us 35.6853 round off 1 dp, 35.7 degrees. All right. So I also write a statement lah. So I'll write maybe on the left. I'll write. So okay lah. Okay, the angle of elevation of B from D is equals to 35.7 meters, 1 dp. Right? It's not meters anyway. It's an angle. Yeah, it's a degree, sorry. 35.7 degrees, 1 dp. All right, so 1 dp. Okay, so yeah, let's move on to part C. Okay, part C in blue. Okay, part C. So length of BC. So okay, very easy already, right? Because we have already found CD and BD, right? BC is just a usual length, so we can just use Pythagoras theorem. So BC square is equals to 10 square minus 8.1223 square. All right, so BC is equals to, just square root this whole thing, and I will have 5.8333. So round off 3SF 5.83 meters. So 3 SF. Oh, again. 3 SF. Okay, so BC is 5.83 meters, 3 SF. All right. Okay, so this is it for question 9. Okay, let's look at the last question for exercise 8.2, which I'm going to cover, right? So 2 points P and Q are 27.6 meter apart on level ground, right? As shown in the diagram here, right? 27.6. Then they said a kite at point A, right, is vertically above Q, all right? And then the kite is attached to a string PA, okay, of fixed length. Okay, so keyword fixed length, which is hinged at P. So it's fixed here, hinged here, and then it will start to move lah. So that means we can say that line PA and PB is actually the same because it's the same identical string, right? So the kite moves from A to B, okay? Because kite, obviously, due to the wind, right, it will move, right? So the kite moves from A to B such that AB is 10, all right? And then angle APB is 18. So find the angle of elevation of B from P, right? So they want angle of elevation of B. So they want the entire angle here. All right. So to start off, right, we need to find out what is the length of the string. All right. So let's label this as X. Okay. So we can say let the length of the string be X meter lah, right? So that means X meter. So that means we are saying that, you know, PA is equals to PB, which is equals to X meter. This is what we are saying. Okay, so how do we find out X? We are going to use cosine rule, right? So 10 square equals to X square plus X square minus 2 times X cosine 18 degrees. Yeah, so we are using this because the PA and the PB is the same length. Yeah, so this only result us in having one unknown, actually, which is X lah, right? So 100 equals to 2X square minus 2X square cosine 18 degrees. Okay, so we need to factorize our X square lah. So 100 equals to X square bracket 2 minus 2 cosine 18 degrees. All right. So X square equals to 100 over 2 minus 2 cosine 18 degrees. Excuse me. All right. So after we calculate all this, right, we will find out that, you know, our X square, right, this is equals to actually don't need lah, just find out X lah. Straight away find X. So it's just square root lah. So X is equals to 31.96226. Okay, so this is the length of PA and PB lah, right? So we can say PA equals to PB equals to 31.96226. All right. So not yet lah, we haven't find out the angle yet. So the angle of elevation, right, is this part here. We know one part is 18, so we just got to find out angle APQ. All right, we can find angle APQ by looking at triangle PAQ. Okay, so because there's a right angle triangle, so we are going to use Tuakaso. All right, so yeah, Tuakaso. So that means this is, so the angle is what we want to find, this angle here. So this is hypotenuse, this is adjacent. So we can say cosine angle APQ, right, equals to adjacent 27.6 over hypotenuse, which is 31.96226. All right, so angle APQ is equals to cosine inverse that value. Okay, let me just straight away find the answer. Cosine inverse this fraction, and then we will be getting 30.2860. All right, so the angle of elevation of B from P will be 30.2860 plus 18 degrees. All right, so this will be 48.2860 round off 48.3 degrees. Okay, 1 dp. Okay, so we can write a statement lah. So on the left, the angle of elevation of B from P is equals to 48.3 degrees 1 dp. Okay, so that is it for part A. All right, now part B in blue. So the height of the kite above the ground when it's at B. So they want this line. Okay, they actually want this line. Okay, the length, right? So yep, so they want this length. So as you can see, I'm going to redraw. So this is part B. So it's like that. Let's just let this be Y lah. Okay, so they want this, and then we know that our BP, right, which is we found it in part A already, 31.96226, right? Okay, then this angle BPY is already found in part A. This is 48.2860. So can find already lah, right? So Tuakaso lah, same thing. So this is the opposite, this is the hypotenuse. So sine law. So sine 48.2860 degrees equals to opposite, which is our by, the length, the height of the kite above the ground, over hypotenuse, 31.96226. All right, so by equals to 31.96226 times sine 48.2860 degrees. So the answer here will be 23 point, give me a while, 23 point, sorry, excuse me. So 83.85904, so round off 23.9 meter. All right, 3SF. Okay, so we can end off by saying the height of the kite above the ground at B is equals to the 23.9 meters, right? 3SF. Okay, so yeah, this is it for question 10.